Welcome to our talk, titled Trust but Verify. You might recognise me. I've been around for a while. I've presented at each one of these Macaducks, Troy McClaw. You might remember me from every other Macaduck. And I'm Principal Software Engineer at Jamf. And Paul?
Hi, I'm Paul. I'm a Client Platform Engineer at Jamf. I work on the auto-uptake product. Like all straight to Betamax spy thrillers, my origin story starts sorting mail in a Virgin Direct post room in the late 90s. I kind of always had an interest in computers, so when I discovered that help desk teams were a thing, I decided that was the career for me. Other than completing Doom and Quake as a kid, I had no real IT world experience to get myself there, so I volunteered my free time for hardware rebuilds, office moves during a site-wide network upgrade from token ring to Ethernet to get myself some experience. This led on to a secondment to the help desk, which then turned into a permanent role. The first 10 years or so were mostly Windows-based roles at Norfolk County Council, James Badger Hospital, Great Yarmouth Waverley PCT. 2006, I joined Cambridge Education Group, where there was a small but quickly growing Mac estate, and then I kind of drifted from Microsoft to Apple. And then I went to Cambridge Education Group. My next role after Cambridge Education Group, I was much closer to home at Norwich University Arts, where I spent 11 years as the technical owner of the Apple estate. As we were coming out of the pandemic, I applied for a role at DataJar to work on the auto-update product. Somehow managed to convince Ben and Yanis that I was a man for the job, which is a decision I'm sure they regret at least every other day. So sorry about that. Yeah. DataJar was then acquired by Jamf, and I moved over to continue work on the rebranded Jamf auto-update product in the app lifecycle and software update teams.
So the context of what we're talking about today is around Jamf auto-update, as Paul mentioned a moment ago. It's our automated packaging and deployment system for Jamf Pro. So we've got a large volume of titles in there. We use things like auto package and Monkey to generate the data we need and deploy stuff on disk. It's very much what feels like an App Store-like experience. It installs the latest version of an application in machines. It notifies people when stuff's been installed. You can also uninstall those type of options as well. When we originally started out, and this is kind of how it works out with Paul and that, we had one certain route that we were going with checking the validity of items. And what you're going to see from here is how Paul's taken that and extended it much, much further.
Okay. Secret agent duck. Okay, so trust but verify. It's a phrase you're probably more used to hearing in the identity space, but it's actually an old Russian proverb, and it rhymes in Russian, and I hope I get this right. Dovrei no proverei. Apology to any Russian speakers in the house if I butchered that.
Does anybody know if that was butchered or not? All right, it's flawless then. It's fine,
Great,
it's flawless.
perfect. The phrase became internationally known thanks to an American scholar called Suzanne Massey. She met with Reagan many times between 84 and 87. She taught him the proverb and told him, Russians like to speak in proverbs. It would be nice of you to know a few. You're an actor, you can learn them quickly. Reagan loved it and adopted it as a signature phrase when discussing relations with the Soviet Union. He used it so often at the signing of the INF Treaty on the 8th of December 1987, Gorbachev finally replied, "You repeat that at every meeting." Reagan's response was, "I like it." A fun side note, while Reagan was quoting Russian proverbs, Gorbachev was quoting Ralph Waldo Emerson back at him. The reward of a thing well done is to have it done. Emerson had apparently been popular in the USSR when Gorbachev was at uni. The phrase has had a long afterlife too. In 2001, the National Infrastructure Protection Center published a paper called Trust but Verify about protecting yourself from email viruses. In 2013, John Kerry updated it for the Syria chemical weapons deal, where Reagan's old adage, where he said, saying Reagan's old adage was in need of an update. And that they'd committed to a standard of verify and verify. In 2020, Pompeo went even further, saying the US should distrust and verify when dealing with China. But for many in IT today, it's the foundation for zero trust security models and the perfect lens to think about how we verify software before it hits our fleets. So we ran a quick poll in the Whoever app, and there's been some encouraging responses. Looks like most of you are already doing some level of verification before deploying to your fleets, which is great. We've also got someone at level 4, which is brilliant. Hopefully by the end of this session, we convince a few more of you to go the full dossier.
Level 0 is the YOLO level, right?
It is the YOLO level, yeah.
So again, to kind of give you more context, talk about the evolution of this. When we started out originally with the auto-update side of things, we would mostly encounter issues or vulnerabilities like these three here, where each of these three, the application itself from a vendor was re-signed with someone else's identity and malware or malicious code and stuff was put into the product. Now, it's quite easy to check that as well. There's a couple of binaries we've got within macOS which you can use. We've got the code sign binary, which will check the application. And then on here, this amber note here, that's the team ID. So when you get a certificate from Apple as a developer, you get these identifiers. So what this is basically doing, it's saying this application, Google Chrome app in applications, is signed by this team, and that team we know it's Google themselves. You can do the same thing with packages as well. And here, for example, it's saying that this package itself is signed by Jamf software. So you know that the item you've got was downloaded from a vendor and it's valid for that vendor. Likewise, you can also use SPCTL for this as well, and it also gives you notarization status. So you've downloaded the thing, you trust it's from the vendor, you verified it's from the vendor. And that was kind of the basic model that we followed originally with Jamf Auto Update. And then what happened was things got a bit more complex. Things got more complicated and needed further checks. For example, these items here, they're what they call supply chain attacks. And what this means is the part of the product has been swapped out with another malicious version, and then the vendors then built their app and signed it with that malicious code in there. So the code signature of the app is still the vendor's code signature, still signed by the vendor, but malicious code has been injected in there. And this kind of actually tied in with Paul joining DataJar, and then realising that we need to extend out further from that code verification.
Yeah. Okay. Yeah, so before I joined DataJar, as Ben was saying, he was already doing the code signature verification and some VirusTotal checks on new titles that we were adding. I followed in those footsteps, but got increasingly concerned about the risk of inadvertently adding compromised software to the catalogue. Blog posts like Objective-C's, the Lockbit ransomware kind of comes from macOS, kind of just drove it home because VirusTotal didn't initially flag anything untoward with the Locker Apple M164 sample. But I'd noticed a pattern in Patrick's blog posts where his tools just stopped previously unknown malware without any specific knowledge of them beforehand. So I just began by adding the tools to my test devices and just observed for any suspicious behaviour while testing the installs and uninstalls. That kind of evolved into a checklist that I'd fill out for every title and just attach that to the new title ticket request that we had in. So this is the checklist that we originally had, and we just use it as an installation test snapshot. Covered a bunch of things that I'd sometimes forget to add to recipes, the link to VirusTotal from where we checked it, code signing, screenshots of any triggered Objective-C tool, what config profiles the title needed, and whether a PKG had deprecated dependencies like Python 2 in its scripts. With the pace of the new title request we received, it was manageable, but it was a bit of a faff filling it out, making sure we got the screenshots, the command output, and it was definitely still prone to human error, so it's super easy to forget to take a screenshot or miss checking something off the list. And the irony that I created the list in the hope it would stop me forgetting things isn't lost on me. So what do we do now? Well, last summer we had a batch of about 20 new titles come in at once, and the thought of going through that checklist one after the other just kind of filled me with dread. And I'd had the idea to write an automation script to cover quite a bit of the testing, but I knew it'd be quite complicated, so it just kind of stayed an idea. But thankfully, this batch of 20 coincided with the release of an internal AI tool called Ask Jamf, And I figured this was the perfect opportunity for me to test out the new tech and write the orchestration script I had whirring in the back of my head. I've now migrated to using Copilot agents and Claude, which is much quicker than the copying and pasting I was originally doing. When we test new titles, we always test on actual hardware, and we test on both Apple Silicon and Intel. Although I'm a great believer in any testing is better than no testing, one of the main reasons we test on hardware is malware authors are sneaky buggers, and they'll often check to see if their code is being executed inside a VM or a sandbox, and then bail before anything malicious tries to run to avoid discovery by security researchers. So, what does the script do? Hang on, I'll go back. So we collect system data, the tool state, what's installed, version numbers. We start monitoring logs. We scan the media. We then install the media. We analyse what gets installed on disk. We then do an uninstall, stop the monitoring, and then we compile a markdown report, and then we decide whether it's okay to add or not. These are the tools that we use. It forms the backbone of the security checks. So let's take a closer look at each of them. VirusTotal, most people know this one, but we use it in two ways. We upload the install media itself, and we scan that, and then we submit any URLs or IP addresses that we capture by Lulu during the launch of the app or the install phase. You need an API key. The free tier is okay. There's a 600 megabyte limit on uploading media, which should cover most things, not all, unfortunately. And this is okay for business workflows as long as you're uploading new samples. VirusTotal shares submissions with the security community, so you just need to be aware if you're testing any confidential internal software that happens. So in 2018, OS X Dummy targeted the crypto community and was completely undetected. 0 out of 60 AV engines flagged it on VirusTotal. Similarly, in 2023, the Trojanized 3GX supply chain attack shipped a malicious libffmpeg dilib that was notarized by Apple and undetected by every AV agent on VirusTotal when it was first uploaded. Cases like these show why we can't rely solely on VirusTotal. Okay, so I think this is a little bit of an exclusive first look. Jamf Threat Labs provides a dedicated macOS binary scanning service where VirusTotal scans the install media as a whole. Threat Labs goes deeper and it scans the executable binaries, validates macOS headers, runs YARA rules, and classifies threat levels. To use it in the script, we need an API key. That API key has to be renewed every 30 days. This is currently in beta, and it is available for any Jamf customer. And if you'd like an invite to the beta, speak to myself or Ben after the talk, and we'll sort you out. So this is the dashboard. You can see there's an error to upload binaries. You can just drag and drop. You can see your recent submissions with their status, and then some quick stats showing the total submissions and threats detected. The submission table shows the full history with the name, status, and ability to view detailed results for each scan. So let's take a closer look at the view results. 3 examples of the Threat Labs results page. The first one is just a standard scan. Shows threat assessment, file hashes, analysis details, detection methods used, team ID analysis, SHA-1 hash lookup, and YARA rules. The middle one is for AI analysis for a flagged binary. It does a bit of a deeper dive with security classification, threat level, file classification, identifying the type of tool, vendor, architecture, and code sign status. And on the right is a continuation of that with behaviour analysis and reasoning. It examines the binary strings, frameworks, and capabilities to determine what the application's actually doing. In this example, identified a network monitoring tool with socket operations and an unknown team ID, flagging it as a medium threat, requiring further verification. Okay, so Lulu is a firewall for macOS. It monitors all outbound network connections and alerts you when an application tries to connect to a remote server. During testing, we stream Lulu's events by the unified log, capture connections, and submit it to VirusTotal for analysis. It's pretty common to see connections to CDNs and update feeds. And in the real world, in 2018, OS X Dummy tricked crypto community users into running a malicious binary. The malware set up a persistent reverse shell to an IP address on port 1337, giving the attacker root access. Lulu detected this outbound connection immediately, even though every AV engine on VirusTotal missed the malware entirely. BlockBlock monitors persistence locations. Wherever someone tries to install a new launch agent, launch daemon, login item, or other persistent mechanism, BlockBlock raises an alert. We capture these events again through the unified login, and then this feeds into configuration profiles that we generate. In 2018, OS X Dummy again installed a malicious launch agent at library launch daemons com.startup.plist that persisted a reverse shell script. BlockBlock identified this alert and on this persistent attempt and alerted on this persistent attempt immediately. 2026, BlockBlock 2.3.0 added paste protection against the click fix attacks, where attackers trick users into pasting malicious commands into the terminal. North Korean actors use this technique in fake video calls, and LLM-generated instructions were found propagating click fix payloads via Google-sponsored results. Knock scans for persistently installed software. Unlike the streaming tools, this is a point-in-time scanner. We run it before and after install, compare the results. This tells us what persistent mechanisms the title added, launch agents, daemons, login lines, browser extensions, shell config changes. Running knock on a root system infected with OS X Dummy revealed the unsigned com.startup plist launch daemon executing a script from var root. In 2020, the Zoom vulnerability knock detected the proxy library injection in Zoom's framework directory, a dilib that wasn't part of the original application bundle. Okay, so ransomware. This monitors the system for the rapid creation of encrypted files, which is a hallmark of ransomware. When it detects suspicious encryption activity, it suspends the offending process and then alerts the user. Version 2 moved to the endpoint security framework for bot detection. We stream the events during testing to ensure the title under test isn't doing anything that looks like ransomware behaviour. It's not uncommon for apps to encrypt files. For example, Chromium-based apps tend to encrypt files in the user space application support folder. So you really want to be paying attention to where files are being encrypted and how many. In 2023, cross-platform ransomware called Turtle appeared. It was written in Go with builds for macOS, Windows, and Linux. Ransomware generically thwarted it with absolutely no prior knowledge to the malware. It simply spotted the rapid creation of encrypted files by an untrusted process. And there was also a hard-coded AES key called, and it's Woogie123, Woogie123, and Woogie means turtle in Chinese, hence the name of the ransomware. Okay, so oversight. This monitors your Mac's camera and microphone. If any process activates the mic or accesses the webcam, oversight will raise an alert and identify the responsible process. During testing, again, we stream these events to catch anything that silently tries to access audio or video hardware. In 2020, Zoom's process could inherit its mic and camera permissions, recording audio and video with 0 user prompts. Zoom could even be launched hidden via USR bin open -J. Oversight would alert the user anytime the mic or camera became activated, even from a visible Zoom session. Earlier in 2016, Oversight exposed Shazam keeping the microphone active even when the user toggled it off. proving the tool catches both malicious and misbehaving software. Okay, Rekey scans for and monitors core graphics events, keyboard events tabs, the most common technique used by keyloggers. It can scan for existing taps and alert in real time when a new one is installed. During testing, we run a scan before and after install. Any new keyboard tap events by the title under test is flagged. Most legitimate apps don't need to do that, so it would be a kind of a big red flag. The tool distinguishes between passive listeners and active filters, which help gauge the severity of the finding. OS X FruitFly was written over a decade ago, but only discovered in 2017. It installed keyboard event taps to log keystrokes and used synthetic mouse and keyboard events to dismiss security prompts. Even dumping the user's keychain, Rekey would have detected the event tap installation immediately. Okay, DHS stands for Dilib Hijack Scanner. This checks for applications vulnerable to dynamic library hijacking and detects any that have already been hijacked. Dilib hijacking is a technique where an attacker plants a malicious dynamic library in a location that the OS will load before a legitimate one. This can give persistence and code execution in the context of a trusted app. After installing a title, we run DHS to check whether the new application introduces any hijackable paths, or worse, ships with already hijacked libraries. In 2020, Zoom's macOS client had a disable library validation entitlement, allowing any library to be loaded into its process space. By proxying a legitimate SSL library, an attacker could inherit Zoom's mic and camera access. Completely invisible to the user, DHS would flag the hijackable dilib paths. Many other apps, including Microsoft Office, have had similar vulnerabilities in the past. Okay, XProtect. Most people know about XProtect. It's Apple's built-in antivirus that uses Yara signatures to detect known malware. Works in 3 layers by preventing launch via Gatekeeper, blocking known malware from running and remediating infections that slip through. Signatures are updated automatically independently of the OS. XProtect scans app on first launch and whenever they change on disk. We monitor XProtect events during testing via the unified log, watching for any malware detections or quarantine actions triggered by the title under test. In 2025, Apple pushed XProtect 5304 with substantial new Yara rules for a malware family codenamed Bonsai. 5 variants, including Bonsai, Barricade, Blaster, Bonder, and Banana. Security researchers linked these to DPRK's Blue North group targeting crypto and Web3 platforms. Malware was a stealer written in Go, targeting browser extensions for Chrome, Brave, Edge, and Firefox. Apple also used MRT to forcibly remove Zoom's vulnerable web server component from Macs Worldwide in 2019. And it's the only time they've ever taken action. Okay, so one of the more useful outputs of the script is the automatic generation of config profiles. The key insight here is, does the access request make sense? Zoom asking for camera and mic, it's pretty reasonable, right? Text editor asking for camera access, bit of a red flag. A calculator wanting Zoom full disk access, bit suspicious. We check these because of just-in-time enrollment. macOS does a just-in-time model for permissions. An app might not request access to camera, microphone, or file system until it actually needs to perform that action. So you can't just install an app and wait for prompts. We need to check the entitlements, the info P list, and declarations up front to know what it's asking for. We check the NS usage description keys in the info P list to see what the app declares when it needs, and we verify those claims against actual code signing entitlements. So we can't solely rely on the entitlements and NS usage description keys, because not all developers declare them properly, and some don't declare them at all. An app might install helper tools, background agents, login items that don't show up in the main app entitlements. So we go beyond entitlements and look what's actually installed on disk. We use SFL tool dump BTM, which dumps the background task management database, which tells us all the login items, launch agents, daemons, regardless of what the developer has put in their entitlements. There's definitely some overlap here with block and knock, but we want to make sure we catch everything possible, so we just kind of throw in the book at it. We also enumerate system extensions with system extension CTL. By combining these on-disk sources with the entitlement and persistence data from the other tools, we generate accurate PPC login items and extension profiles that reflect what the app actually does. Okay, so it generates a markdown report. We'll just go through some examples of it. So we collect the system information of what we are installing on. You can see here it's got the macOS version, the architecture, the user, admin status, where it's physical hardware and the serial number. We then detect the security tools installed and their version numbers, and then Rosetta compatibility. As we all know, that's going to be deprecated in the next OS, so we need to know whether it will run on the latest OS or not. We then do a bit of monkey catalog validation just to make sure that we've got the version numbers correct and the minimum OS versions all match. We then record the successful test install. We check whether it loops on install, loops on uninstall. And then we do some package analysis, which just checks for deprecated things like Python 2 and Bash, which is also deprecated. Then record what VirusTotal tells us. So we've got the report URL, whether it came back clean, how many detections it got. And then the threat lab scanning. So what the script does is it traverses the entire media and grabs anything that's an executable Mac-O, and it uploads to the binary scanning service, and then reports on it there. We've just got 2 here, but it found 5. And they all kind of came back clean on that one. Yeah, some more security events. So it records what knock finds, what block finds, and DHS. The DHS one, it just found a BB edit, which is unrelated to the application we were actually testing. Okay, so here we can see we scanned the IP address that Lulu found with VirusTotal. Again, came back clean, which was fine. No oversight triggers, no rekey triggers, no XProtect. It did trigger ransomware. There was 3 files. We're just showing 1 here. And it's been truncated a little bit for space, but it encrypted some stuff in the application support. Yeah, and there's no system extensions found, no managed login items needed. We checked the notifications database, and it registered an inactive app. We just do that just to make sure that we can create the notifications profiles that we can then give out to customers. It records the uninstall and then the code styling of the app. And then it records the configuration profiles that we found. So it found that it does need notifications, even though it didn't actually trigger it when it was run, and a screen recording profile. Okay, so I think we've got time for a quick demo, so I'm going to try and do a live one, if I can. small out. Okay, so the script needs to run under sudo, and first we need to configure it, which is configure edit. And from here we can add the VirusTotal API key, ThreatLabs API key. We can choose whether we want to extract an icon, whether we want to create an extension attribute based on the monkey catalog information for like PKG receipt or CF bundle version. We want to include a license header in the EA. Whether we want to auto-create the configuration profiles. There's also an option to just do a standard install by dragging and dropping a DMG or a PKG. So we'll say yes to that. Enable ThreatLabs scanning. Yep. Knock will also do VirusTotal integration, but that consumes quite a lot of the free API quota, so we generally say no to that. And then, yeah, it's just the license name. Log lookback time, we'll go for 20 minutes. The default monkey catalog, we'll go test in, and then you can set the manifest name if you want to test. And then where you want to save the output, we want downloads. And then, yeah, that's just the name for the config profiles, and then the reverse domain for that. And then just the title of the report. And then you can choose here whether you want a monkey local manifest test run, a manual test run, or a monkey standard. This is set up for a monkey standard, so we'll go for that one. And then we just do configure. You can see that this is saved, so it's now saved to the current user install audit.json, and that can be edited from there. To run it, we just run main, and this will pick up the default that we've set in there, and so you can just hit enter. This is the manifest we want to use. So it's a standard monkey setup with a server-based manifest. The titles are added to the catalog, but they're not added to the managed installs or managed uninstalls because we just kind of manipulate that locally. Okay, and it brings up a list of things we've got in the catalog. So let's go Google Chrome. So we'll install that. It's just doing a test check of the notifications database. And it's doing a baseline scan of knock, so we can do some comparisons later. Let's make it a bit bigger for everyone. Okay, it's now downloaded the software. We're going to analyze the package. We're going to upload it to VirusTotal. We're going to extract all the macOS and upload into ThreatLabs. Hopefully it won't take too long on the internet here. Yeah, you can also see that it's scanned it for any deprecated dependencies. So now we're installing the software. We're checking for install loops, and then we have to run the application itself. So you can see XProtect doing its thing, or done its thing. Okay. So yeah, you can see Lulu's blocked the alert. This is likely just to talk to its CDN, so we'll just give that an allow. We'll allow those. And we just do a simple test. Okay. So we'll close the app. How long you want to keep that running for, just to see if anything happens, you probably want to run it a bit longer than that, just to make sure no persistence events occurs or anything. So we hit enter. You can see it's now scanning the IP address that Lulu blocked and we allowed, and it's now doing another knock-knock scan so we can do a comparison. DHS is something that has to be run manually. Unfortunately, there is no command line for that. Normally, I would run this with a full system scan, but for speed, this is just a normal quick one. And you can see that it's found BBL, it's got a vulnerable path, but that's not related to Chrome, so we can ignore that for now. We drag the application in, and this is where it does the code signing checks, and it checks the entitlements, and you can see that, you can see it creates, or it will create some config profiles. You can drag as many applications as you want in. That will loop through, because many application installers, they can install multiple apps at a time. This is only one, so we'll click continue. And you can see that it's created PPPC, notifications, and manage login items. We're then checking the notifications database again, and we're ready to uninstall. So it's now done the uninstall. Okay. Doing the uninstall, and this bit is pretty cool because not all apps tell you exactly what they want to do or it launches. So you can manually create a profile that wasn't picked up in the initial scan. So we'll just quickly do yes, and we'll generate a screen recording one. And it picks up the bundle ID and the team ID, the default app name, and we hit quit. And then it's just created you a config profile there. And I think we're at time, unfortunately. So we'll just quickly get back to the old one. Sorry, hang on. So we'll close that, fine.
So thank you all for listening. Up there's a link to a GitHub repo, which we're going to make public shortly, which has the script in there and that as well. I hope you found that of use. Obviously, there's a lot of depth there to that. There's lots of those products are out there. You could spend 30 minutes talking about one of those products on its own, but hopefully showing you the context and the workflow it's been helpful. Also, the script itself was
pure vibe coded.
And there's even a script that generates the slides that was also vibe coded. You're fully leaving that. They'll all be in the GitHub repo. Yeah, by the end of today. But obviously, if you've got any direct questions, let us know. And again, if you want to be on the Jam Threat Lab side of things as well, we just realised we're keeping you from lunch.
If anyone wants to see any of the other workflows in action, feel free to grab us. We're here all day.
And just to say, this is Paul's first public presentation, so...